Hi, my name is Patricia and this is my amusement park screencast. The ride I will be talking about is the Tower of Doom at Six Flags America, and the standard applied is PD-19. Here is my diagram of the Tower of Doom. The total height from the ground to the top of the ride is 42.7 meters. The length of free fall is 21.6 meters, which means that the height of the end of the free fall to the ground is 21.1 meters. Here are the data tables of time that I collected for the time it took to reach to the top of the ride and the time the ride is in free fall. The video I used is about to be shown. Here is the video that I used to collect my data. I did 5 trials for each data that I needed to collect, which was the time it took to reach the top and the time the ride is in free fall. And after averaging them all out, the time I got for it to reach the top is 20.68 seconds, and the time the ride is in free fall is 1.91 seconds. The first problem that I needed to solve is what is the velocity as the ride goes to the top. And to do that, I use this equation: x2 equals x1 plus v1 plus 1 over 2at squared. And x is 0 because we're still at the ground. x2 is 42.7 because that is the total height of the ride where we end up. v1 is what I'm looking for. v2 is still unknown. Acceleration is assumed to be 0, and the time is 20.68 seconds because that's how long it took to get from the ground to the top of the ride. After plugging in what I know into the equation and solving, I got that v1 is 2.06 meters per second. Next, I am looking for the free fall acceleration. x1 is 42.7 meters because we are at the top. x2 is 21.1 meters because the ride is 21.6 meters that falls, which is 21.1 meters high off the ground. v1 is 0 because we are still at the top. v2 is unknown. Acceleration is what we're looking for, and the time is 1.91 seconds because that is how long the ride is in free fall. After plugging in what I know into the equation and solving, I get that the acceleration is negative 11.87. And this is okay that it is negative because the ride is coming back down to the ground. Finally, I am looking for the velocity at the end of the free fall, and this time I'm using a different equation, which is now v2 equals v1 plus at. v1 is 0 meters per second because that is the velocity when the ride is waiting at the top. v2 is what I'm solving for. A is negative 11.87 meters per second squared because that is the free fall acceleration that I just solved for. And the time is 1.91 seconds because that is how long the ride is in free fall. After plugging in what I know into the equation, I find that the velocity at the end of the free fall is negative 22.67 meters per second. And it is also okay that it's negative because this is still when the ride is coming back down to the ground. Thank you for watching my screencast. Bye.